Welcome to Study Loop.
In this session, we want to derive the we want to find the intensity formula for diffraction using from n slits. Okay, so so this is the diagram that we are going to draw, and then we want to we are kind of guided. So there are 5 parts in this question. Okay, so in part A, we want to find the electric field at point P, where point P is a point on the screen. Okay, yeah, and it is very far from the slit, and then the slit separation is D. Okay, so we are going to write down the electric fields at point P due to from different slits. Okay, point P, the electric field from different slits. Okay, R. Okay, so I label 1 to be at the bottom and go up to n, and E1. Okay, we will write it as E naught cosine k times big R minus omega t. Okay, and then E2 will be E naught cosine kr minus omega t plus phi. Okay, and our phi is the phase difference due to path difference. Okay, so we have this relationship, phi divided by 2 pi equals to lambda over no, equals to d sine theta over lambda. Okay, so phi is equal to 2 pi d sine theta over lambda. Okay, so this is our phase difference. And then we can do E3 will be E naught cosine kr minus omega t plus 2 phi, and then you keep doing this, and then you get the electric field due to the nth slit, and you get E naught cosine kr minus omega t plus n minus 1 phi. Okay, and then the electric field at point P at an instant will be E1 plus E2 plus E3 plus up until En. Okay, so it will be E naught cosine kr minus omega t plus E naught cosine kr minus omega t plus phi plus E naught cosine kr minus omega t plus 2 phi, and so on until you reach the last term. Okay, and it's En E naught cosine kr minus omega t plus n minus 1 phi. Okay, yeah, and shown. Okay, so this is how you obtain the electric field at point P. Okay, by just summing up E1, E2, E3 until En. Okay, so just summing up all the contributions by each from each slit. Okay, all right. Okay, then in part B, okay, we are asked to show that this thing, okay, the summation, okay, the real part of this thing is equal to EPT, okay, electric field at point P. So for the first thing we'll do is we'll use the Euler formula. Okay, so e to the I theta, right? Right, e to the I theta equals to cosine theta plus I sine theta. Okay, so you can use this relationship and you can write, there's a E naught. Okay, E naught cosine kr minus omega t plus n phi plus I sine kr minus omega t plus n phi. Okay, and if you take the real part of the summation, okay, then you are just going to extract the cosine term, okay, because that's the real part. Okay, then if you expand the summation, okay, so you start from n equals to 0, and then you do n equals to 1, okay, and n equals to 2, and then you continue on, you get to the last term. Okay, and you realize that this is just EP t, okay, and shown. All right, so that's how you show that the real part of the complex exponential, sum of the complex exponential gives you the EPT. Okay, so why we want to do this is that it is easier to do the summation in complex exponentials, and then later when we want to find the EPT, then we just take the real part of that sum. Okay, so that's the rationale. Then we go on to part C. Okay, in part C, we want to show that the summation of the complex exponential, okay, can be simplified into the given expression. So I'm just going to proceed on to show how you can obtain that. Okay. Okay, so this is the given summation. Okay, the first thing is I'm going to pull out the constant term, the terms that does not involve n, small n. Okay, so E naught e to the I kr minus omega t does not contain n, so you can pull out from the summation, and what you are left with is summation from n equals to 0 to n minus 1 e to the I n phi. Okay, so this thing, okay, is a geometric sum. Okay, so we can use the formula for the geometric sum. Okay, okay, so you have the last term minus the first term divided by the ratio minus the first term. Okay, so then you can put this thing into here. Okay, so okay, E naught e to the I kr minus omega t e to the I n phi minus 1 divided by e to the I phi minus 1. Okay, and then we can pull out some terms. Okay, so in the numerator, we are going to pull out e I n phi divided by 2, and then we have e to the I n phi divided by 2 minus e to the minus I n phi divided by 2. Okay, and then in the denominator, we are going to pull out e to the I phi divided by 2. So we have e to the I phi divided by 2 minus e to the minus I phi over 2. Okay, and then we are going to absorb this term into here. Okay, so we have e naught e I k r minus omega t plus n minus 1 divided by 2 phi e to the I n phi divided by 2 minus e to the minus I n phi over 2 divided by e to the I phi over 2 minus e to the minus I phi over 2. Okay. Alright, so this is what we managed to get. Okay. And then we want to find the real part. Okay. So we want to find electric field at point P. Okay, is equal to the real part of the summation. Okay, it is also equal to the real part of the term above. Real part. Okay, so when it comes to taking the real part, this term will get the cosine. Okay, then for the term in the fraction, okay, so here we'll write 2i sine n phi divided by 2 divided by 2i sine phi divided by 2. Okay, so you can cancel the 2i and you get e naught cosine kr minus omega t plus n minus 1 divided by 2 phi sine n phi over 2 divided by sine phi over 2. Okay, so one thing about, we have this formula e to the I theta minus e to the minus I theta. This is equal to 2i sine theta. Okay, so you can kind of say it that way. Okay, you just use the Euler formula. Okay, this is how you get it. Okay, yeah. All right, so we are done for part C. Okay, all right, next we will do part D. We want to find the intensity. Okay, so intensity is proportional to electric field at point P. Okay, mod square and the time average. Okay, so we'll do the time average of the cosine term first. Okay, so this time average is half. Okay, and so I will be proportional to E naught square over 2 sine square and phi divided by 2 divided by sine square phi divided by 2, and then we write it as equal to I naught sine square and phi divided by 2 divided by sine square phi divided by 2. Okay, sure. Alright, so this is our part D. And then in part E, we want to put big N equals to 2 and see what we get, and compare that with the formula we obtained in the double slit interference. Okay, so when N equals to 2, okay, so our N is equal to our intensity. Okay, intensity is equal to I naught sine square phi divided by sine square phi divided by 2. Then we will use the double angle formula for the numerator. Okay, 2 sine phi cosine phi over 2. Okay, yeah, 2 sine phi over 2 cosine phi over 2, and this whole thing is squared divided by sine squared phi over 2. Okay, so the sine term is cancelled out, so you get 4 I naught cosine square phi divided by 2. Okay, we want to compare this with the equation in 35.10. So equation 35.10 is so equation 35.10 is okay, I prime equals to I naught prime cosine square phi over 2, right? And then in that case, I naught prime is proportional to 2 E naught square. Okay, our case, okay, our I naught is proportional to half E naught square. Okay, so this is equal to I naught prime divided by 4. Okay, which is, so E naught square is I naught prime divided by 2, and multiply by half, you get I naught prime divided by 4. So you get I naught prime equals to 4 I naught. Okay, so this means that the two equations, okay, are equivalent. Okay, the two equations are the one obtained in part D, and the one equation 35.10. Okay, yeah. All right, so that's how we show that they are equivalent by using this relationship. Okay, so that's all for this question.